Welcome back to Foundations of Math 11, doing quadratic functions. Today we're going to look at analyzing the graph of a quadratic function in vertex form. So let's just recall what we've done already. A quadratic function is a function in degree 2, which can be written as f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c, where a, b, and c are all real numbers and a is not equal to 0. When you graph this, it's a parabola. A parabola has a minimum point, that is, it opens up if a is greater than or equal to 0, so that means it looks like this. And it has a maximum point, so it opens down if a is less than 0, and a, of course, cannot be equal to 0. The vertex of the parabola is either the maximum point or the minimum point, and the maximum or minimum value of a quadratic function is the y-coordinate of the vertex. All right, so we're going to go to Desmos and look at a couple of functions. So just remind you, it's just desmos.com, and graph these functions and what do you notice, and then expand g of x, and what do you notice? All right, so pause the video, do that, and then come on back and see what we get. Well, hopefully what you noticed is that these are the exact same graph. So if I click on this little blue circle here, it makes the blue line disappear. So I can see that the blue line is directly over top of the red line, and those two functions are exactly the same. Okay, so let's just record that over here. They are identical graphs. And then it says to expand g of x. So that means multiply it out, which you may or may not remember from last year. So let's try that. So it's x minus 3 squared, but I'm going to write that as x minus 3 times x minus 3 because that makes my multiplication easier, plus 2. And then I'll just remind you of FOIL. So first, outer, inner, last. So I'm assuming that you learned that last year. I don't know any other acronym for that, so I'm going to assume that that's the one you learned. So we have x squared minus 3x minus 3x plus 9, and then plus 2, and that equals x squared minus 6x plus 11, which is the same as f of x was. So those are equivalent. All right. Let's try that again. There are two more functions for you to try on Desmos, and so go do that, record what you notice, and then come back. All right, let's see. Again, these are the same graph. They are the same function. They're just written in different shapes. Okay, so let's come over here, and again, they are identical graphs. And show that they both represent the same function. So that means I need to manipulate the equation of one to look like the other, to show that it's the same as the equation of the other. So I'm going to do the expansion again. So this is going to be negative 3 times x plus 5 times x plus 5 minus 2. So that's negative 3 times, I'm going to put some square brackets here. This is going to be x squared plus 10x plus 25. I did shortcut that a little bit. It would be plus 5x plus 5x, and then minus 2. And then I need to multiply everything that's in these brackets by negative 3. So this is negative 3x squared minus 30x minus 75 minus 2, which is negative 3x squared minus 30x minus 77, which does equal that one. Okay, so again, they are the same function. So, all right, The quadratic function can be written in two different forms. There's the general form, which we looked at before yesterday, and this is officially called the standard form, but we're actually going to call it the vertex form because that's the information it gives us. And personally, I always get confused between standard and general, and it's not important for you that you have the right names between standard and general. So use general for the one that we did first, and this we're going to call the vertex form. And there are two ways that it's represented. F of x equals a times x minus h all squared plus k, or y equals the same thing. Or sometimes the letters used are p and q. So we're going to use h and k because that's what your practice work uses. I may slip into P and Q sometimes because that's how I learned it. All right. And what's useful about this is what's the information that's in there. Okay, let's do an example using the vertex form. So we'll use our technology to graph the function 2 times x minus 3 all squared plus 4. So I have that graph there. What is the vertex of this? So if I just click on the graph, it highlights the vertex for me, and the vertex is 3, 4. So let's actually do a really quick sketch of this graph here. And when you're looking for, when you're doing a sketch, really all you need is, that's about 3 and then 4. And then I'm going to draw my parabola going up from there. Whoops, do a little better than that. Not much apparently. Put some arrows on it, and then mark that this point is 3, 4. Okay? And what I want you to notice is that when we write this as y equals 2 times x minus 3 all squared plus 4, the 3 and the 4 are the vertex. Okay? Let's graph another example. Y equals x plus 2 all squared minus 5. And this time the vertex is -2, -5. And I'll do my quick sketch. My vertex is down here. And if you notice that the equation, the standard form or the vertex form up here, it's written with an x minus here, not a plus, okay? So what you want to do, what I'm going to do here is I'm going to write y equals x minus. So if I change x plus 2 to x minus something, that's going to be x minus -2 all squared minus 5. And then my -2 and my -5 are my vertex. All right, so here's the thing to remember. When a quadratic function is written in vertex or standard form, y equals a times x minus h all squared plus k, the vertex is at point h and k, okay? So having this as a minus is super important, okay? And a is the same as it is in the general form. Remember when we did when we did the examples on the previous page where you multiplied things out, your a value stayed the same. That's really, really helpful. All right, let's take a look at how that is useful. All right, without the use of technology, write the equation of a quadratic function in vertex form with the following characteristics. So there's our formula. If we want it in quadrant 1 opening up, so maybe this one, our h and k are both going to be positive. So in this case, my hk is 4, my vertex is 4, 3. So my equation is going to be y equals And a can be anything. I'm just going to leave it as 1 this time. So y equals x minus 4 all squared plus 3. Okay, here's my h and k. If it's in quadrant 3, opening up, my vertex is at -5, 1, 2, 3, 4, 5, 6, -5, -6. This is my h, this is my k. My equation is y equals x minus h, which is -5 all squared minus 6. And I so strongly recommend that you write it out this way with the minus negative when you write it out. It just makes, I'm always a fan of fewer errors. And then change it to x plus 5 squared minus 6, because that's how we usually write it, okay? Vertex on the x-axis opening up. Let's put it right here. Okay, so my vertex this time is at -2, 0. So y equals x minus -2 all squared plus 0. And then I'll simplify it to y equals x plus 2 all squared. And then I don't write the plus 0. Okay. Last example here on the y-axis opening down. So let's put it down here where it's out of the way. And my vertex this time, I was aiming for that intersection there, that lattice point. My vertex this time is at 0, -5. So y equals x minus 0 all squared minus 5, which becomes y equals x squared minus 5. And I don't need the brackets around the x anymore because there's nothing to group it with. Okay, so those are just some examples of what your equations will work with. Really, the biggest thing here, honestly, is write your equation out as x minus something, and then I guess I could have gone plus 6 here. That would have been more consistent. But that one is not as confusing as this because you're adding it. This one where you're subtracting it, more mistakes happen. Don't worry about which quadrant is which. I'm pretty sure this is the only time we ever use it. Yeah. All right, example 3. Consider the graph of the quadratic function f of x equals 2 times x plus 6 all squared minus 9 without using technology. Okay, my advice, write this out in the proper form. So this is f of x equals 2 times x minus something all squared plus something, okay? And then what are our somethings going to be? This plus 6 needs to be minus -6, and this is going to be plus -9. So when I've written it that way, how easy is it to see what the vertex is? The vertex is -6, -9. It's just so much easier. The equation of the axis of symmetry. Remember, this is an equation, and the axis of symmetry goes through the x value of the vertex. So this is going to be x equals -6. Does it have a maximum value or a minimum value? Well, a equals 2. So a is greater than 0. Therefore, it opens up. And if it opens up, it has a minimum value, which is the y value of the vertex, which is -9. State the domain and range of the function. The domain is XER, because it's all the real numbers for x, and the range is y such that y, now it's got a minimum value, which means that y has to be greater than or equal to -9, and y-er, because it can be any real number. Oh, that was a terrible bracket. Let's fix that. Curly brackets. All right. Determine the y-intercept of the graph. Okay, so the y-intercept is when x equals 0. Okay. There are going to be a bunch of times in this unit where you need to do calculations like this. So you need to understand what the y-intercept is so that you can plug that value into the equation and see what the y is going to be. Okay. So we're just going to take the equation, which is f of x equals 2 times x plus 6 all squared minus 9. And we're going to change that x to a 0. So this becomes 2 times 0 plus 6 all squared minus 9, which is 2 times 6 squared. This bracket should be on the other side. 6 squared minus 9 equals 2 times 36 minus 9, which is 63. Okay, so the y-intercept is 63. Okay, you could also say that that is at 0, 63. Those are the coordinates of the y-intercept. Either one of those is okay. Now, just to check this, let's go to Desmos and graph it. Okay, so we'll just pop over to Desmos and we'll change our equation to 2 times x plus 6 minus 9. Okay, our vertex is at -6, -9. The axis of symmetry would go through here, would be x equals 6. Actually, let's graph that. X equals, -6. There we go. That's our axis of symmetry. Minimum value, the smallest the graph ever gets, is right here, -9. Okay. And the y-intercept, we need to scroll way up here. Whoops. But if I click on this, it highlights that point for me, 0.63. All right, we were able to get all that information just from the graph from the equation. We didn't need to graph it. Okay, one more thing to look at here, the number of x-intercepts. We can determine whether a quadratic function will have 1, 2, or 0 x-intercepts based on the position of the vertex and the direction of the opening. So let's just sketch the graph of a quadratic function with 2 x-intercepts. Okay, so 2 x-intercepts, it has to open towards the x-axis. Okay, so it can either go like this or it can go like this. So the opening here has to be from the vertex, it has to be towards the x-axis. So an equation of this could be y equals 2 times, let's do this one, 2 times, this is what, like 5, -1. So my vertex here is 5, -1. So this would be x minus 5 all squared minus 1. All right. To have one x-intercept, vertex has to be on the x-axis. And that means that the k value is 0. So let me do this one here. Okay, so the equation of this graph would be y equals -1 because it's going down, and then x minus 0 plus 1 because the x-intercept is actually, or the x value of the vertex was supposed to be at 0. And then, sorry, plus 0, this should be a 0. Okay, let me do another one here. Over here, this would be y equals 1 times x minus, let's call that 4. I mean, we don't have any scale on here, so it doesn't really matter, but this point could be 4, 0. And then it would be plus 0. Plus 0. Okay. And to have no x-intercepts, it would open away from the x-axis. So it could be here like this, or it could be here like this. So this one, if this was at, let's call that 3, 3, this would be y equals 1 times x minus 3 all squared plus 3. All right, let's summarize what we've learned here. The coordinates of the vertex, when we're looking at the graph with this equation, y equals a times x minus h all squared plus k. The coordinates of the vertex are h, k. Remember, this has to be minus, that's really important. The equation of the axis of symmetry is x equals h. If a is greater than 0, the parabola opens up, and the vertex is the minimum point. And the range of the function is y such that y is greater than or equal to k, right? Because it's got to be bigger than this value. This is hk here. And y is an element of the real numbers. If a is less than 0, the parabola opens down, and the vertex is the maximum point, because it goes like this now, hk. And the range of the function is y such that y has to be less than or equal to k, and y is a real number. And the domain of the graph is xer. X is all the real numbers. All right, that's it for this lesson. You can go and do the practice work, and I'll see you in the next video. Bye.